Hey, this is Math 6, Unit 8, Lesson 9, Interpreting the Mean as Fair Share. So we're talking today about what we call the mean, and we're saying that is really what we talk about when we're talking about having a fair share of something, which means that it's kind of like what everyone would get. It's what everyone get if you distribute things equally. So it's what everyone would get if you distributed equally. And we'll explain that more as we go along, okay? But the idea is if you had something and you split it up and shared it equally, and everyone got the same amount, that would be the mean. So first of all, we have close to 4 as an activity. It says use the digits 0 to 9 to write an expression with a value as close as possible to 4. Okay, each digit can only be used one time. So we're going to take some numbers and we want to add them up and divide them by 4 in order to get to 4. Okay, our goal is for this to equal 4 altogether. So think of it this way, first of all. This whole chunk right there, we can call that x. Divided by 4, we want that to equal 4. Okay, that's what we're saying with all this stuff here. So what does x need to be? Well, let's first of all remove the 4 from the denominator by multiplying 4 on both sides so that x equals 16. Okay, see how we did that there? So that means the sum of all these need to equal 16. So we want to use the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, any 4 of those to add up to 16. That's the idea. So I just started with 1 and 2, got me to 3, and then I got 3 more, which got me to 6, and I went, okay, well, 1 plus 2, 3 is 6. I want to get to 16. I can't do it with that, right? Because I need a 10. Can't use a 10. So let me make this a 9. So now I have 6, 7, sorry, make it a 7, 6 and 7. So what I need left? I need a 9. So this all equals 16. Are there other ways to do it? Absolutely, and I would encourage you to think of some more. But the key was to kind of think through, what does this have to equal? What does the sum of all this need to be in order to divide it by 4 and get to 4? So we figure that out. All right, let's move to kittens. The kittens in a room at an animal shelter are placed in 5 crates. 1, 2, 3, 4, 5 crates. The manager of the shelter wants the kittens distributed equally among the crates, which right now they're not. So how could you do that? Well, you could ask the cats to move into the crates equally, but probably they're not going to listen because they're cats. That's the way that works. The better way to do it would be to add up how many kittens you have, 2 plus 1 plus 4 plus 3, and see how many you have in total. This becomes 7, 8, 9, 10. And then we want to take the 10 kittens and then we want to share them with the number of boxes that we have. So let's say we have 5 crates. Well, if I have 10 kittens, I put 1 in each one first, so 1, 1, 1, 1, and then I'd put in 2. And we can count them up and we have 10. So what do? We took the, what did we do? We took the 10 and we divided it into 5 groups to show us that there should be 2 kittens in each crate. That's how we distribute things equally, which is really what we're talking about when we're talking about the mean or the average. So the number of kittens in each crate after the equally distributed is called the mean number of kittens per crate, or the average number of kittens per crate. Explain how expression 10 divided by 5 is related to the average. Well, 10 is the total shared among 5 boxes for 2 in each evenly. All right, and that's what that is, which is what we did right there. It's the 10 kittens, total 10 kittens shared among 5 boxes to put 2 in each one evenly. Now another room in the shelter has 6 crates. Oh boy. And no 2 crates has the same number of kittens, and there's an average of 3 kittens per crate. Draw or describe at least 2 different arrangements. Well, I'm going to do one with you at least, since we're working from home, or maybe you're working your teacher's not here today. So no 2 crates is the same number. Let's first of all figure out how many do they have altogether. Now there are 6 crates already, right? That's the crate number of crates, and we're going to multiply that by the average. Now the average per crate is 3, and that's going to give us the total number of kittens we have, which in this case happens to be 18. All right. So our total number of kittens we're working with is 18. It helps us start there a little bit. All right. Now, knowing that, we're going to want to have 6 crates. So 1, 2, 3, 4, 5, and 6. And we're going to divide that by 6 to come up with the average of 3. We already know that this total needs to equal what? It needs to equal 18. So we want to think about numbers we can use to come up with 18. So here's kind of what I did. I started this way. I said, well, let me think about, I'll do a 2 and a 3 makes 5. And then I went with another 5 for 10. I did a 6 and I got to 16. I did a 0 and then I went, I have 2. Now that's 18, but I used a 2 twice, right? So I really can't do that. So I need to change something around a little bit. So I can change, I have 5, I can do 6 and 2. 6 and 2, I can swap that out because 6 plus 2 is what? Is 8. So I can swap that out for a 7 and a 1, and I still have that equal to 8. Now I have 0 plus 1, this is 8, 8 is 16, and I have 18. Just a little bit of trial and error here, right, is what I did. Are there other ways? Absolutely. But I could have boxes with those number of kittens in each one, divided by 6 for an average of 3, and that works out just fine. Are there other ways? Definitely. So if you figure one out, I would recommend that you play with it a little bit. It'll help you with your homework and working independently later on. So the next question says 5 servers were scheduled to work the number of hours shown in the table. They decided to share the workload so each one would work equal hours. So on the left-hand side of the grid, draw 5 bars whose heights represent the hours worked by servers A, B, and C. So server A worked 3 hours. So put that there. Server B worked 6 hours. So we can go up to 6. Server C worked 11 hours. D worked 7 hours. And E worked 4 hours. So already what we're seeing is like they worked a lot more than they probably needed to, or some people worked more than the other people. So we want to get these evened out. So how do we do that? Well, I'm going to go ahead just so we can see here. I know it's hard on my photocopied paper. I'm already missing my lines a little bit. Okay. Just kind of see where we are. One thing I notice is that I'm kind of on an average line somewhere about 6 is what it looks like. So what I want to do is think about how you would rearrange the hours so that each server gets a fair share. Okay, so if I think about A, well, what I think about first of all is I see that A is, if I'm going for like this line right here, A is about 6 blocks short, right? So 1, 2, 3, 4, 5, 6. I'm about 6 blocks short from being equal there. And E is about 2 blocks short from being equal there. So if I just took away this block, 1, and moved it over there, and then 2, because that needed 2, and this one needed 3, 1, 2, 3, okay, and I divide those out there, now everybody has 6 blocks, and I have 1 block left over, right? I'm taking those 5 blocks there and putting it with A and E, so everybody has 6, and I have 1 block left over. Now that 1 block has to get split up between everybody, so maybe I just have a 1/5 of a block all the way through. So everybody gets 1/5 of the block. So we'll take one of the blocks here, it's not that size, and we're going to turn that into a 1/5 of a block there. Does that make sense? So we took the yellow and we added 2. We added 2 to this one. We added 3 to this one. I took away, well, I actually took away 5 from this one, and I took away 1 from this one. Okay, now I didn't just add 2, I added 2 1/5 to make it even, but that's kind of the idea. So based on your second drawing, which I just drew on top, what's the average or mean number of hours? So it's a little bit more than 6, and what we did is we did about 6 and 1/5 because we took a block and we broke it up into 5 different pieces. Or you could say it's 6.20 if you wanted to make that as a decimal. So how can we also find the mean by doing this? Well, this number 31 is the total number of hours worked by the people divided by 5, the number of servers, and that gives us our average 6 1/5 or 6.20, and that's the average time or the mean time that everyone worked if they're going to share the time equally. Now, which servers can see the biggest change? Well, the biggest change was server C, right? Server C worked, in our case here, about 5 hours less. It was actually 4 4/5 hours, but it doesn't matter. Who saw the least change? That's the person who's closest to the original part. And the least change is right here with B. B added 1/5 of an hour to their normal work day. So that's your change there. So we're taking away from people that were over 6 and we're putting out there to make an average. We're distributing things equally, and that is really the whole idea here. Let's take a look at one more activity related to the mean. For the past 12 school days, May has recorded how long her bus rides to school take her in minutes. The times she recorded on the table. So this is the times for 12 times. Find the mean. So to find the mean, what do we need to do? We need to add up all of these values. We're going to add them up. And when you add those up, we end up with 102. So the mean is going to be the sum of all the values divided by the number of values. So that's our total, divided by the total we had, which was 12, by the number of items, and that's going to give us our mean. So 102 divided by 12 is 8.5. So what does 8.5 mean? So what does the mean tell us about the trips to school? It means that on average, it takes her about 8.5 minutes to get to school. And that's what that is. Now, is it exactly 8.5 minutes? Nope, and it varies, and that's okay. But on average, 8.5 minutes is what it takes to get to school. Sometimes it's a little bit more, right? But sometimes it's also a little bit less. For 5 days, Tyler has recorded how long his walks to school take in minutes. The mean for his data is 11 minutes. So it's about 11 minutes to get to school. Without calculating, predict if each of the data could be Tyler's and explain your reasoning. Okay, so the mean, again, the way we get the mean is we take all the numbers. We're going to take number, 5 numbers. We're going to divide that by 5, and we should get 11, which means these numbers here should be a total of 5 times 11. They should add up to about 55, because 55 divided by 5 is 11. They should also be somewhere near 11 all the time, okay? When I look at data set A, I have one value that is 11 and the rest are less than 11. This tells me that I'm going to have a mean that's going to be less than 11. I can't get up to 11 really if all the numbers are below 11. It's going to be tough to do, right? It's like dividing 40 divided by 5 and hoping you get 11. I'm going to get like 8. It's not going to work. Over here, now this one here, this is a little different, right? You have the numbers 7, 9, 12, 13, and 14. Now 11 as a mean would be somewhere about here. And we could see that this might work. These numbers here are all around the 11, right? The numbers are distributed around the value 11 of where it would be. So this one is a maybe, okay? I'm going to put that down as a maybe there. For the next one, we have 6, 9, 10, 11, and 20. Now, granted, 11's right there, and this is pretty close to it, so those are pretty close together. This one's way larger, though, than these guys, but that difference could make it so it's pretty close. This is kind of a maybe as well. It might work, it might be close, just because of the differences between those numbers. Over here, again, we have an 8, a 9, a 10, 11, and 11. So again, these three numbers are all less than 11, so you can't combine them in a way that's going to join those to make the average equal to 11. So this mean is going to be less than 11. So we would say no to data set A and D. So now let's find out which one actually works. So when you add up B's total, the sum of B is 55. The sum of C is 56. So now when we divide those sums by 5, we get our means, which are 11 here, and 11.2. So the one that's the actual data for Tyler is data set B. All right, so that's the idea there. Let's take a look at your summary. In summary, sometimes a general description of a distribution does not give enough information, and a more precise way to talk about center or spread would be more useful. The mean, or the average, is a number we can use to summarize distribution. It helps us talk about that center and that spread, which means we're looking for that fair share or leveling things out there. So that's what we're doing today. So let's look back at our notes if you need to, but we're going to go ahead and look at your homework. So take a pause, work on your homework, and then come and check it together in just a few minutes. All right, homework time for lesson 9. A preschool teacher is rearranging 4 boxes of playing blocks so that each box contains an equal number of blocks. Currently, box 1 has 32, box 2 has 18, 3 has 41, and 4 has 9. What are all the ways they can make the same number of blocks? Well, what I started doing was first wondering, well, how many blocks are there actually what we're talking about? So I added those up. 32 plus 18 plus 41 plus 9 gave me a total of 100 blocks, and I know that there are 5 boxes. So if I'm going to have an equal number, I'm going to do 100 divided by 4. I'm looking for about 25 in each box. So what are the ways I can get 25 in each box? Well, could I remove all the blocks and make 4 equal piles of 25, then put each pile in one of the boxes? Yep, that would be pretty easy to do. What if I take 7 blocks from box 1 and put them in box 2? So subtracting 7, so minus 7 you get 25, adding 7 you get 25. That's great, but these boxes are still not working, so that doesn't work. What if I remove 21 blocks from box 3? Well, box 3 is 41. If I take out 21, now I have 20. And if I put those in box 9, I have 20 plus 9, which is 29. That doesn't help at all. 7 from block 1, put in box 2. We know that's good. 21 from 3 and put them in 4, we know that's bad. So that second part doesn't work. So that's a no. 7 from 1, put them in 2. That's good. How about 16 from box 3? So 41 minus 16 is 25. We take those 16 and add them to box 4, and we're 25. So that's going to work with that combination. So E is also a good idea. Number 2. In a round of mini golf, Claire records the number of strokes it takes to hit the ball into the hole each green. She says she redistributed the strokes on different greens. She could tell that her average number was 3. Well, let's see. How is she correct? Let's find the sum of all this. So all these add up to what? All these add up to 27. When you add them up, 27. And we divide that by how many holes? 1, 2, 3, 4, 5, 6, 7, 8, 9. Divide that by 9. And so her 3 is her actual average or her mean. So that's how she is correct. Good job. Number 3, 3 6th grade classes raised this much money, and this much money for their classroom libraries. They agreed to share the money equally. So what's the equal share? Well, to do that, we're going to add those up. 2550 plus 4975 plus 3725. And we're going to divide that by the 3 classes to find out what that share is going to be. That's going to be equal to, this all works out to be $112.50. And when you divide that out by 3, you get $37.50. And then finally, number 4, our last one I think of the day here. Yep, nope, a couple more actually backside. They give 4 quizzes. They're all worth 5 points. After 3 quizzes, she has a 4, 3, 4. And what does she have to get on the last quiz to get a mean score of a 4? A couple ways of thinking about it. She has a 4, she got a 3, she got a 4, and then there's something else she has to get. All of that combined needs to divide by 4 in order to equal 4. Okay? So we're going to find out what goes in this X spot, or if you want to put the box like we've been doing before, you know, what goes in the missing space there to make that work. Now think about this. She already has 4s. Those already average out to 4. So what does she have to get for her last one to make these 2 things average out to a 4? And in one sense, she lost a point there. She lost a point. So over here, if I'm looking for a 4, I need to add 1 more to it, so most likely I'm going to have a 5. Now, is there another way of thinking about it? Sure. This becomes 4 plus 3, I can think of like an equation like this. 4 plus 3 plus 4 plus x divided by 4 equals 4. If I multiply 4 by both sides, then I have 4 plus 3 plus 4 plus x equals 16. 4 plus 3 plus 4 is 11 plus x equals 16. We subtract 11 from both sides, and x equals 5, which is what we have right there, and that makes sense. Because we lost a point there on that second quiz, we need to get one more point in order to make it up to average of 4. All right, let's turn the page. Which container tends to have the longest worms? We have a lot of worms here again. He's measuring 25 earthworms in 2 different containers, container A and container B. So A and B. Which container tends to have longer worms than the other one? So longer is going to be of a greater length. We see this one goes out to 65. This one goes out to 65, but then continues this way. Plus, it has a lot more values here, greater than 45. So we have a lot more in the larger section in container A, has a longer worms. Which container would 15 millimeters be a reasonable description? So kind of like that middle point, right, of a typical length. So 15 millimeters. Well, 15 is right here for this one. Does that seem like a pretty good one for all the data? No. 15 is here for this one. Does that seem like a good one for all the data? Well, it's pretty typical, at least for that cluster. So B is a better choice there. If length is related to age, which container had the most young worms? Well, young worms going to be shorter. So which one had shorter worms altogether? We would say right there, that cluster in B. And finally, number 6. Diego thinks x equals 3 is the solution of that equation. Do you agree? Well, this is x squared. X squared means we take 3 and we multiply it by 3. 3 times 3 is 9. And last time I checked, 9 does not equal 16. So we would say Diego needs to check his math. All right, that's it for today. Have a great day, and we'll see you next time.